So in this lecture we will basically see how controlling mechanism, that means how we control the operation of semiconductor device, that means SCR. Okay, so here we see how we control SCR. Okay, so see here exactly we see which parameter we need to control. Okay, for control the performance of operation of that particular device. Okay, so first we'll see when we have used the rectifier. So first we will see when we use rectifier using diode. We have already studied half wave rectifier, full wave rectifier, and in this rectifier we use diode for converting AC to DC. Okay, so in this rectifier, in that rectifier the input is basically AC and we convert that AC form into DC form. So either your rectifier can be uncontrolled. So that mean if you have AC supply and you use an uncontrolled device can be listed. We know uncontrolled device is diode. Okay, and this device convert your AC into DC form, and that DC is a fixed DC form. Okay, that means a variable AC supply is converted into fixed DC voltage. Okay, by using uncontrolled device. Uncontrolled device is our diode. Okay, but what if I want to variable DC. Okay, so for attain variable DC voltage at output, you should have the controlled rectifier. So you have a single phase AC supply voltage, and at output you will get variable DC voltage. Okay, variable DC voltage where the load can be connected and you can measure voltage across this load. Okay, you can measure voltage, power, energy by across this load. Okay, so whenever it is an uncontrolled device, that means rectifier using a diode. When it is a control device is nothing but SCR. So this is okay. So see the last figure. In block I have used one symbol. This symbol is basically represent SCR. Okay, so this symbol represent basically SCR. So see here, AC supply can be converted into variable DC supply through this SCR. Now here when we work with AC supply, we know that if SCR is used, SCR is control device. That means it can be turned on by triggering, okay, or by gate triggering. Okay, so we turned SCR by this gate. Okay, so this is called gate triggering. Okay, okay, so generally we use gate triggering for trigger SCR. So this is gate terminal. So this is our gate terminal. Okay, so if we provide gate current, you can control the operation of SCR. So your SCR will be either on or it will be off. If your SCR is off, gate current is provided, SCR will be turned on. that is a turn on mechanism of SCR. Okay, so if your SCR is off, gate current is provided and SCR will be turned on. This is called turn on mechanism of SCR. And this will start converting from AC to DC. Okay, now when we go for AC, we have seen a different turning of mechanism, and it can be either natural or it can be a forced. But when it is forced, we have input as a DC voltage. So if you have a voltage DC at its input side, you need to have force current commutation or voltage force commutation. But you go for AC as a input voltage and your commutation as a natural commutation. That means AC signal is this. Okay, AC signal is this. So see, this is at input we give AC signal. Okay, so for first half cycle, our SCR will be remain on. So as our voltage go to the 0 value, so for first half cycle our SCR will be remain on. So as our voltage go to the 0 value, our SCR will be turned off because at our gate anode to cathode current goes below the holding current. Okay, so control device which can turn off naturally or automatically, these devices are known as commutated device. Okay, so in this lecture, what we need to remember? So first of all, if we want to variable DC voltage from AC voltage, then you should go for control rectifier. In control rectifier you can design with thyristor, or you can say you design control rectifier by SCR. So see, if we want to variable DC voltage from AC voltage, then we require control rectifier. Okay, and we design control rectifier by using thyristor or SCR. So SCR is a control device, and this SCR can controlled through by gate terminal, or it can be triggered by using gate current, and it can be naturally commutated. Okay, so basically these are the advantages of SCR. Okay, so this is the advantage of SCR, because through gate current we can adjust the voltage what we want, so we can get the variable DC voltage from AC voltage. So this is our one advantage of control rectifier. Second advantage is this is commutated device. Okay, so phase control rectifier preferred over control rectifier. Okay, and this control rectifier can design by thyristor. Okay, so in this lecture I have discussed about I have given a small introduction of phase control rectifier device. Okay, so here see, here see, this is the these are the line commutated AC to DC converter. So in line commutated converter, types of input is fixed voltage, or it will be fixed frequency AC power supply, and type of output of line commutated converter is variable DC output voltage, and type of communication is natural or AC line communication. Okay, different types of line commutated converters are, first is AC to DC converter, this is called phase control rectifier. Second one is AC to AC converter, this is AC voltage controller, this is known as AC voltage controller. And third is AC to AC converter, this is called cycloconverter. Okay, so this is used at low output frequency.